after a couple periods of looking at right triangles. Okay, now, at first glance, there doesn't look like there's anything different with this triangle, but there is. Okay, let's take a look at it. Consider kind of my way of saying maybe there's something that you know about this. Maybe there's something kind of new. And I think both those things are true. Okay, so we got a triangle, pretty common. We're actually going to have triangles for next many, many weeks. But we got an ABC. I'm going to tell you that side C is 30. I'm going to tell you that side A is 21. And, of course, we're telling you that there's a right angle. But that's it. Okay, now, it would kind of depend on sort of where you're at from yesterday and even right now today that you would realize that there's something different about this. Okay, I haven't given you an angle. Usually that type of problem kind of sticks out a little bit. I haven't given you an angle. Now, the deal with that is that you have to find the angle, but the thing that usually gives kids the trouble is kind of just knowing where to start. Okay, you kind of feel like someone should tell you, hey, go find angle B or go find angle A. I want you to understand that you can start wherever you want. Okay, so if, and I'm trying to change things up a little bit, if I decide to find angle B, just because, well now, okay, now we can get some things in motion. And again, I find that this is the thing that gives kids the most trouble is just saying, okay, if that's the angle I'm trying to find, then this is the opposite. You mean I can say that? Yeah, I can say that. I can say that side B is the opposite. But that's because I decided to find an angle B. Of course, this would be the adjacent, and everybody gets the hypotenuse correct. Okay, but before we go any further, the whole reason I can write this stuff on the board is because I just decided to find angle B. And the reason I'm making a big deal out of that is because sometimes that's just tricky for kids to just pick something to start with. Now, if you're saying, why don't you find angle A? We will. Okay, we will. But if we're finding angle B, now it's time to think about the trig function. Okay, now yesterday we had this, okay, little pick a trig function idea. Okay, it changes just slightly today. It changes just slightly to say, now I want to pick a trig function that uses what I know and know. Did you see what I did there? I want to pick a trig function that uses what I know and know. What do I mean by that? Well, it's usually pretty clear that you know these two numbers. Well, you want to pick a trig function that uses adjacent and hypotenuse. Adjacent and hypotenuse. Boom, 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 boom. Boom, cosine. Okay, so we're going to use cosine because that uses what we know and know. It uses adjacent, which is 21, over the hypotenuse, which is 30. Now look, it is the new part here this morning. The variable is the angle. The variable is the angle. Okay, so it's the cosine of big B. The cosine of big B. It turns out that you have to do something a little different on your calculator. And if you do this, you're silly. Don't be silly. Don't do that. See what I did? I just kind of did it like yesterday. Okay, now if you do that, I don't know what you're going to get. It's not going to make sense. Here's what I want you to be. I want you to be a student of algebra. This is an algebra equation. We want to get rid of cosine. How do you get rid of cosine? Well, to divide by cosine would actually also be silly because I'm not multiplying by cosine. So I can't like say, hey, divide by cosine. It just doesn't mathematically make sense. But I do want to do the inverse. If you're thinking you want to do like the inverse or the opposite, you're right. Let me introduce to you the inverse cosine. It's literally a button on your calculator. Now, what you're seeing there is algebra. Algebra says do something to this side, do the same thing to the other side. So I'm now going to be able to cancel my cosines, which leaves me with b. See how that works? I cancel the cosines, which leaves me with b. But ultimately, it's just something a little different on your calculator. Now, you have to find the inverse cosine. You probably have seen it. It's right above the cosine. It's either shift cosine or second cosine, or maybe it's in a menu. Maybe it's in a menu, but you have to find that inverse cosine. Okay, don't hide if you have a question like with your calculator trying to get 45, but play along and please ask if you need something. You should be getting 45 and some. Okay. We'll go to 2 decimal places just to keep things pretty standard. Here, let's kind of try it again. Actually, I want to talk to you about angle B. I'm sorry, angle A. Okay, angle A. Now, listen, just like yesterday, there's a couple ways to find it. Okay? There's a couple ways to find it. Ultimately, I want you to be able to find it, but I also want you to understand that sometimes it depends on the scenario, what method you might use. So let's kind of get it out there. There's absolutely nothing wrong with basic geometry that 180 degrees makes up the triangle. So find what's left, find what's missing, find angle A. Okay? Again, I'm standing here saying that's fine. You can do that kind of thinking. I actually would hope that you do. But I'd like to show you a way that uses sine, cosine, or tangent, and not just to kind of waste some time, but because there might be a time where that's the better way. Okay, now here's the deal. If I'm going to use sine, cosine, or tangent, I kind of have to go back to the drawing board here and literally back to making a decision. And the decision is to find angle A. Now, maybe that was what I wanted to do first, okay? But here's the deal. If angle A is the one that I'm referencing, now this side becomes the opposite. Now this side becomes the adjacent. Okay, now this is important because what you should realize is that the sides have switched. The words have switched. So, and that's all because angle A is now the one that I'm going to reference. How does it work? You want to pick a trig function that uses what you know and know. I know the opposite. I know the hypotenuse. Opposite, hypotenuse. Pick up the phone and you're going to call sine. You're going to call sine. It turns out that the only thing that's really different is the trig function. Okay, but I want you to understand that sine is what's going to help us get angle A. Okay, because we are referencing angle A. And it also comes out to the same answer, which is cool. I mean, that's the way it's supposed to work. You still get 44. I don't want to confuse you, okay? But I do know that there's going to be some times where maybe angle A is the only angle that you needed. And so just jump right into sine. But maybe angle B is the only angle you needed. Okay? It's going to depend on the scenario, kind of which one that you pick. How about side B? Side B. Let's make sure we go over this because I do know that based on the tests that there were a couple times where you had to use Pythagorean theorem. Okay, I just gave it away. It's Pythagorean theorem that we still make some silly mistakes. So Pythagorean theorem, okay, we all know it's a squared b squared equals c squared. But that doesn't mean that you just add numbers on your calculator. It doesn't mean that you add numbers fact, you know some good algebra that you actually subtract the numbers. Now, if you want to show that stuff on paper, show it. I'm mainly concerned that you do it, and you can also just do it on your calculator. But again, you got to subtract in this scenario. Okay, so I end up with 459, but of course that's not the final answer. You got to take the square root, take care of that business. All right, so be careful about the Pythagorean theorem. It's not really SOHCAHTOA, but it's still right triangles. So it's still part of what we got to do. I want to do another one of these with you, actually. I want to do another one and maybe say, you try it a little bit. You see if you can at least get started. This is not the exit ticket, but it's just an opportunity to see if you guys can kind of get started and get something going here. Okay, so another triangle. But as you sort of survey the situation here, you quickly realize there's no angles. Except for the right angle, there's no angles. Find one. See if you can find one of the angles. And remember how we kind of did with the other problem? You have to pick one of the angles. You have to pick one of the angles. Some people find angle A first. Some people find angle B first. Just pick one of them. Okay. Maybe you're the type of student that you just kind of want to see an answer, you want to compare it. So I'm putting some answers up. If you're getting these yellow numbers, awesome. Okay. If you're not, maybe we can see if we can figure out. If you were going after angle A, do you realize that that would make this side the adjacent? If you were going after angle A, this side's the adjacent. So it's an adjacent hypotenuse scenario. Adjacent is what I know, hypotenuse is what I know. That's why we're using cosine. Okay, so if you're doing angle A, you're doing cosine. If you went after angle B, using trigonometry, now this side is the opposite. Again, if you're going after angle B, this side is the opposite. Of course, opposite and hypotenuse is what I know, and that's why we're going to use sine. It does change depending on which angle you're looking for. So I changed side B from adjacent to opposite, or vice versa. Okay, and then just do the inverse of those. If you do the inverse, you end up with the answers that I already put up here. 42 and oops, darn it, this is supposed to be a B, my fault. So, and then angle B is 47. Pythagorean theorem for that side A. Pythagorean theorem. Inverse. I want to show you this because it's important. You always use an inverse when you're looking for an angle. Okay, I'm talking about on your calculator. You always use an inverse when you're looking for an angle. Maybe that seems kind of obvious, but it's just an important idea that actually will pop back up in a few months when we're doing something else. So I want you to hear that. You always use an inverse when you're looking for an angle. Okay. Let me give you the exit ticket because it kind of gives you a chance to once again realize, do you know what's going on? You can ask question on the exit ticket, but I want you to kind of dig into it, find out if you have any questions. Put it on a piece of paper that you can turn in. So, half sheet of paper, trade it with your neighbor. Whatever you want to do. Again, half sheet of paper, full sheet of paper. Okay, I kind of like to see where you're at. Now, if you discover that you're having a question, that is still fine. I can talk to you about this. You actually can talk to each other too. You may talk to each other if you want to compare what you're doing, but I can be somebody that still helps you here. The directions would be to find everything, okay? You're trying to ultimately solve for each missing dimension.